Welcome to 7.6. In this section, we are going to discuss rational exponents. So as you can see from the first objective, first we are going to learn to write expressions with rational exponents in both radical and exponential form. We're also going to be simplifying. Before we jump into any examples, we need to talk about the two different forms, and that's exponential and radical form. So exponential is something like a to the power m over n. Now, this can be converted into radical form. So radical form is going to have a radical. A goes underneath the radical. So the question is, where do the m and n go? That n is the index. That m is the power. Now there's two different places that power can go. It can go all the way outside, or we also have the option of putting the m underneath. Either one works. Either one is correct. You're going to have to choose which one is more appropriate, just based on convenience for you. So the first thing that we're going to do in this video is convert between the two. If we look at example 1, it says convert from radical to exponential form. So x is our base, so this is going to be x to some power. As we look up above, our index goes in the denominator. So index down here is a 5. Our power goes in the numerator. So likewise on b, m is the base. Our index goes in the denominator. Our power goes in the numerator. So that's going to be for the first part of your classwork when you come to class, is converting between those two. You also need to be able to go the other direction. So that's example 2. This time we have something in exponential form. It needs to go in radical form. So we're going to have a radical and the base goes underneath. Remember that our denominator is the index. So that means 4 goes here. Our power can go inside the root, or it can go outside the root. Now, a power of 1, you don't really need to write. So either one of those answers will work. If we look at part B, B is the base. Our denominator is our index. And then k can either go in the root, or it can go out of the root. Now, being able to convert between the two forms is going to be very important for the next set of problems we're going to do, or the next tasks we have. What we're going to do next, what this leads to, is evaluating. If we look at A, we are evaluating 25 to the power 3 over 2. You are not going to be permitted a calculator for this, or I don't want you to put it in a calculator. I want you to be able to do this without a calculator. Now, 25 to the 3 over 2, we can't do that right now in our heads. So let's convert forms and see if that helps. If I put 25 underneath the radical, 2 is my index, and 3 is my power. Now let's think about this logically. Do we really want to cube 25 and then break it down? No. That's not going to be helpful to us. So what I'm going to do instead is I'm going to put that cubed outside. And I'm going to deal with the square root first. Now the square root of 25 I should know. Square root of 25 is 5. And then I can bring that power down. And 5 to the third is 125. Okay. B is 64 to the negative 2/3. Okay, first thing I want to talk about is negative 2/3. Negative 2/3 means that one of those numbers is negative. So I can make the 2 negative or the 3, but not both. Okay, so 64 goes underneath our radical. Now, have we ever had a negative index? A negative index. So our index in this case is a 3, since that's our denominator. Have we ever had a negative one though? No, we've never looked at a negative index. So this here does not make sense. We don't want a negative 3 as our index. So this is what we're going to do instead. So we are going to opt for this one. So our -2 is going to be our power. Again, we need to ask ourselves, the way I have it written right now, is that helpful? Am I going to do 64 to the -2 power? No. No, I want to do the cube root first, and then I'll do the -2 at the end. Cube root of 64, you have two options. Either you can break that down, or maybe you know the cube root of 64. Cube root of 64 is 4. So I get 4 to the -2nd. Now be careful. 4 squared is 16. 4 to the -2nd is 1 over 16. 1 over 16. Okay, we're going to go on and do problem 11 before we move on to some more problems. Again, we're going to switch forms. So this is the 4th root of 1 over 81 cubed. Now, how do I take the 4th root of 1 over 81? Well, if you're taking the root of a fraction, you can break that root up. So this is really the 4th root of 1 over the 4th root of 81. 4th root of 1 is just 1. The 4th root of 81 is 3 to the 3rd. So then I get 1 to the 3rd and 3 to the 3rd. 1 to the 3rd is 1, and 3 to the 3rd is 27. Now, before we move on real quick, for those of you who have trouble with this, the 4th root of 81, I want to remind us real quick how to do that. 4th root of 81, you need to break that 81 down. So I get 9, 9, 3, 3, 3, 3, looking for 4 at a time. So for me, I've done this a lot, and I can do the 4th root of 81 in my head. If you can't, that's okay. Draw the tree. It should get pretty quick though for you as you do more and more of these. Okay, let's move to the next page. In example 4, we are now going to simplify expressions using properties of exponents. This isn't really new. These are things that we've looked at before. So in A, we have 5 to the 1/3 times 5 to the 3/4. Few things that I want us to notice. Remember, we can only multiply these because we have the same base. So we have the same base, that's really important. So we need to ask ourselves, what do we do with those exponents? Sometimes we might think to switch forms. And so we do this. Now, that does not look helpful. That is not helpful, that's not going to help us. So instead, let's think of properties of exponents. If I have 5 to some power times 5 to some power, what do I do with those powers? Hopefully we remember that we add them. Okay, I'm going to need a little bit of room to do this, and so I'm going to write it off to the side. So I have 1/3, and I'm adding 3/4. Remember, when adding fractions, you need a common denominator. Our common denominator in this case will be 12. So I need a 4 here, and I need a 3 here. So I have 4 over 12, add 9 over 12, which gives me 13 over 12. So my answer then is 5 to the power 13 over 12. You could also display this as the 12th root of 5 to the 13th. Either of those are acceptable. Okay, in B, we have x to some power to another power. So we got to ask ourselves, what are we going to do with these powers? Hopefully you remember we multiply them. So we have 3/8 times 4. I would suggest we put that 4 over 1. We're not cross-multiplying. Okay? We only cross-multiply if there's an equal sign between the two fractions. In this case, we just multiply across. So we get 12 over 8. That can be simplified though. If I divide by 4, I get 3 over 2. So this is really x to the power 3 over 2. Again, we could write this as the square root of x to the 3rd. So either one of those will be acceptable. Okay, C. This is a tricky one. What some people think to do is, I'm just going to divide out the 7s. Can't do that. Can't do that. Now, it'd be helpful if that 7 in the numerator had a power. Well, let's remember it does, it's just not written. That 7 in the numerator has a power of 1. So now I'm dividing two 7s, same base. I gotta remember, what do I do with those exponents? So there's another exponent rule. Well, in part A, when we multiplied the two bases, we ended up adding the exponents. So in part C, when we're dividing the bases, we want to subtract our exponents. Okay, so I'm going to again do this off to the side to make sure I have enough room for myself. I need a common denominator. 1 is really 3 over 3. So I get 2/3. So this is 7 to the power 2/3. Okay, in part D, I want us to be careful here. So we might think, I'm going to divide the 18 and the 9. Well, am I allowed to do that? When am I allowed to do that? Okay, well, let's rewrite this. In this case, because both have the same denominator, it might be helpful to write both the numerator and denominator in radical form. So I have the 4th root of 18 over the 4th root of 9, all to the 3rd power. So this is the same as the 4th root of 18 over 9 to the 3rd power. Okay, now I've gotten both the 18 and 9 underneath the same root, so now it's fair game to divide them. 18 divided by 9 would give me 2, so I have the 4th root of 2 cubed. Or I could write this as 2 to the power 3/4. In general, I'm not going to care what form you use unless the problem specifies. So please make sure you do read the problem carefully to make sure that you are able to use either method, unless I ask for one specifically. Okay, we have one more example, example 5, that has a few parts to it that we're going to talk about some of the rules, the can and cannots. So in problem A, part A, square root of 10 times the 4th root of 10. And so we ask ourselves, can we multiply these? No. No. So right now, these cannot be multiplied. Why? Because we have a different index. So different index, we can't multiply. Okay, that doesn't mean we're done with the problem, though. It might be helpful for us to switch forms. If we switch to exponential form, we might be able to use properties of exponents. So on this first one, there's an index of 2. It's just not written. So that's 10 to the power 1/2 times 10 to the power 1/4. Okay, this is looking better. Now I can use properties of exponents. If I'm multiplying the same base, so the 10 and the 10, I'm going to add those exponents. If I take this out to the side, I have 1/2 add 1/4. If I multiply by 2, I get 2/4 add 1/4, which is 3/4. So my answer ends up being 10 to the power 3/4. Okay, then we get to B. So a lot of us see x and x and we want to divide out those x's. Can't do it. Can't do it. And why can't we do it? Because they have different indexes. If we look back at D above, this one up here, we ended up dividing the 18 and the 9 because both had the same index. We could put them under the same root. We can't do that in B, though. We can't do that. So right now, we're kind of stuck. If you're stuck in one form, try the other form. So in this case, in the numerator, there's an index of 2. It's just not written. Denominator is x to the 1/3. Now I can use properties of exponents. If I'm dividing the same base, I'm going to subtract their exponents. Remember, you're going to need a common denominator, so I'm going to multiply by 2 here and by 3 here. So this becomes x to the power 3/6 minus 2/6, so x to the power 1/6. Okay, last one that we're going to do together is part C. We have the fifth root of 2 times the fifth root of 64 divided by the fifth root of 4. Okay, so the first question is, can we multiply all of those and divide? In this case, yes, because we have the same index. Very convenient. So in the numerator, I'm going to get the fifth root of 128. Denominator, I have the fifth root of 4. Can I divide those? Well, yes, I can. They have the same index, so I can put them underneath the same root. So then I end up with the fifth root of 32. Don't think you're done yet. You got to ask yourself if that can be simplified. Let's try. 32 is 16 times 2, so this is 4 times 4, 2 times 2, 2 times 2. Index of 5 means we're looking for a group of 5, which we have. So final answer is just 2. Okay, I know this section is tricky. The biggest idea is you need to know how to switch between the two forms. You need to know how to switch between the two forms. If you're trying a problem and you're stuck in one form, switch to the other form and see if it helps. When you come to class, we're going to do a bunch of practice. If you have any questions, please make sure you write them down. You can email me, ask in class, come to office hours. Make sure if you have questions, if you're unsure, that you ask. I look forward to seeing you all in class.